Welcome back. The objectives of this video is to preview some of the prerequisites as we head into our studies of trigonometry. So we're going to study angles, rotation of angles, standard position, and those types of things. So let's begin with our vocabulary. The standard position of an angle is an angle whose vertex is at the origin. Think the origin of the coordinate plane. And one ray is on the positive x-axis. So on the right-hand side here, we would see that this angle theta, with a rotation indicated by this red arrow, is in standard position. We've got one ray on the positive x-axis and a second ray extending out from the origin, creating that particular angle. Now this angle here, theta, is moving in the positive direction because we're rotating into the positive y-axis or into the first quadrant. If we were rotating the opposite direction into the fourth quadrant, then that would be a negative angle or negative theta. So the initial side of any angle in standard position is the ray along the x-axis. So we would say that this is the initial side. And then the terminal side is the side in which the angle ends. It's the terminal or the ending side, and it's not along the x-axis. Although if we did have an angle of 360 degrees, I suppose the initial side and the terminal side could both be on the positive x-axis. Which leads us to the concept of coterminal angles. Coterminal angles are two angles in standard position that have the same terminal side. So an angle of like 0 degrees and 360 degrees would be coterminal. So coterminal angles would have every multiple of 360 degrees beyond the initial angle. And even a negative angle can be coterminal with a positive angle. So if we said that this angle was 135 degrees, we could have a coterminal angle that would be a negative 215 degrees. Those two angles, negative 215 and positive 135, are coterminal because they end with the same terminating ray. We will also study the unit circle. The unit circle is a circle whose radius is 1 unit long, and it's centered at the origin of the coordinate plane. And points on the unit circle are related to periodic functions. So we know that each one of these points on the positive x-axis is 1, 0, 0, 1, negative 1, 0, and 0, negative 1. So our radius r is always equal to 1 on the unit circle. We have talked briefly about coterminal angles. Coterminal angles are two angles in standard position that have the same terminal side, and they're called coterminal angles. We can find an angle that is coterminal to a given angle by adding or subtracting one revolution, which would be right now 360 degrees. So any given angle has many coterminal angles. For example, we have an angle of 36 degrees is coterminal to 396, 756, negative 324, and negative 684. So we're adding or subtracting 360 degrees or 720 or like multiples of 360 to that 36. So in example 1, we're asked to draw an angle theta of 220 degrees and label as the angle that is coterminal. So let's take a look at that. So 220 degrees, we're going to start in standard position. We're going to pass through the first quadrant, the second quadrant, and extend into the third quadrant. We're about we are 40 degrees into the third quadrant. So our terminal ray would be here in the third quadrant. We indicate by a revolution and an arrowhead indicating the direction that that angle is going. So we can see that that's going in the positive direction. And we would say theta is 220 degrees. And now we want to label theta prime as its coterminal angle. So I'll change colors here, and we'll go in the negative direction. And so that is a negative angle, and theta prime would equal negative 140 degrees. And those two angles are coterminal. And in our note here, we can see that our angle theta can also be 580 degrees, or any full revolution of 220 plus 360k, where k is an integer. And of course, that represents the number of revolutions that we would have, because we're multiplying k times 360, or a full revolution. And we could also do like minus 360k as well. And that would be a negative angle, or negative theta. In example 2, we're asked to find the measures of the angles below. So we want to find the measure of the angle indicated by this arrowhead. So we're moving counterclockwise or in the positive direction. I just think of if we're going up, we're going in the positive direction because these are positive y's. So that's going to be a positive angle. And 180 minus 45, so that angle is going to be 135 degrees. And in example B, we can see here we're going in the negative direction. One quadrant, 90 plus 30 degrees. So this angle is a negative 120 degrees. So one full rotation equals 360 degrees. How many degrees in a quarter rotation? Well, 360 divided by 4 is 90, or a full quadrant. So half a rotation is 180 degrees, and 3/4, of course, is 270 degrees. And those represent the quadrants on the coordinate plane. Let's talk a little bit about reference angles and methods to measure angles. Reference angles, given an angle in standard position, its reference angle is the acute angle formed by the terminal side of the given angle and the x-axis. The angle at left is 210 degrees. So we want to find the reference angle. Well, the reference angle is the angle between the terminal side and the x-axis. So our reference angle, we're 30 degrees into the third quadrant, so our reference angle here is 30 degrees. So our reference angle will always be the angle between the x-axis and the terminal side. So it doesn't matter which direction we go. If we're on the negative x-axis, our reference angle, even though we're rotating in a negative direction, could be like 45 degrees here. Okay. That might be hard to see on the video, but our reference angle is always squeezed between the x-axis and the terminal side. So if I'm in the fourth quadrant, my reference angle is theta, is here. If I'm in the second quadrant, my reference angle is theta here between the x-axis and the terminal side. Think of a bow tie. And visualize a bow tie, and you will see that those are your reference angles, are going to be there. So in example 3, we're going to draw each angle and state the reference angle. So an angle of 150 degrees is going to end up in the second quadrant, and since it's half a revolution is 180 degrees, we're 30 degrees short of a full revolution. So we would say our reference angle would be 30 degrees. And there's our 150 degree angle, and our reference angle is 30 degrees. In B, 315 degrees, we're going to rotate all the way around 270 plus another 45 degrees into the fourth quadrant. So there's our 315 degree angle, and our reference angle theta, our reference angle is 45 degrees there in the fourth quadrant. So 45 degrees is our reference angle, 30 degrees is our reference angle in A. In C, negative 120 degrees, so rotate 90 plus another 30 degrees into the third quadrant. There's our negative 120 degree angle, and our reference angle then, squeezed between the x-axis and the terminal side, is 60 degrees. So we have a 60 degree reference angle as our theta. And finally in D, 140 degrees. We're going to rotate 90 and another 50 into the second quadrant. So I have a 140 degree angle. I'm 40 degrees short of a full or a half a revolution. And my reference angle then is 40 degrees and in the second quadrant. And I do make a big deal about the quadrants because those are going to be important for us in trig. Knowing that which quadrant we're in, location, location, location. Trig is a lot like real estate, and knowing if we're in the first, second, third, or fourth quadrant is going to be critical to our studies. And that wraps up our introduction to trig and some of the basics of angles and angles in standard position and reference angles. And you'll get some more practice with this when I see you in class.